Chemistry is one of those subjects that's all about getting your hands dirty. You're mixing things, you're measuring, you're heating stuff up. But what happens when your classroom is just a computer screen and your students are scattered maybe hundreds or even thousands of kilometers away? Well, that creates this fascinating problem that actually sparked some pretty incredible innovation.
I mean, seriously, think about that. How do you mail a chemistry lab? It sounds like a riddle, right? How do you possibly package up that essential experience? All the glassware, the chemicals, the delicate techniques, and just send it through the post. This was the exact challenge that universities had to solve for their distance education students.
And yet this dilemma, it really gets to the heart of the matter. You've got all these students who need to learn actual, practical skills to get their degree, but they just can't be on campus every week for lab sessions. So for a long time, this was a huge barrier for anyone who wanted to study science from a distance.
And when you put the two experiences side by side, the gap is just massive. I mean, on one hand, you have your on-campus students. They've got an instructor right there, looking over their shoulder. They have access to every piece of fancy equipment, and they can work with their classmates. But the distance learners, they were completely on their own, trying to make do with whatever tools they could get, with no one there to give them immediate feedback. The real challenge was figuring out how to bridge that divide.
So for a while, the best answer they had was something called a residential school. The idea was that students would travel to campus for a few super intense days and just cram an entire semester's worth of lab work. We're talking something like 30 hours of experiments packed into a long weekend. But, as you can imagine, this was far from a perfect solution. It was expensive, you had to take time off work, and for anyone with family commitments, it was a total nightmare. Plus, the research showed that a lot of students just felt completely confused at the time because it was all just so overwhelming.
Okay, so you might be thinking, well, why not just have them do simple experiments at home with, vinegar and baking soda? The researchers were really clear about this. For students who are actually aiming for a career in chemistry, that kind of kitchen chemistry just doesn't cut it. It's not enough. They need to learn real techniques using real lab equipment.
And this is where they came up with something truly brilliant. The solution? Instead of bringing the student to the lab, they were going to bring the lab to the student. And this wasn't just some toy kit. No, this was a full-on, university-level home experiment kit designed for serious science.
So what was actually in the box? I mean, what did they mail? Well, you got real laboratory glassware. Beakers, flasks, burettes, the whole deal. You got a really clever two-pan balance for accurate weighing, a portable pH meter, all the chemicals you'd need for a bunch of different experiments, even equipment for things like distillation and filtration. And to replace the in-person instructor, they included a demonstrator on a DVD to walk you through everything.
And the whole point of this kit was to teach what are called manipulative skills. These are the core physical actions of being a chemist. It's not about just watching a reaction happen. It's about learning physically how to weigh something with precision, how to do a titration correctly, and just how to handle all the equipment with real confidence.
Now, designing this thing meant they had to solve some incredible puzzles. And one of the biggest challenges, literally, was finding a balance. Think about it. A professional lab balance is way too expensive and fragile to ship through the mail. But those cheap kitchen scales you have at home, they're not nearly accurate enough for proper chemistry. The solution they landed on was this beautiful, kind of old-school two-pan balance. It was tough, it was easy to pack, and it could weigh things down to the required 0.1 gram accuracy. Sure, it was a bit slow to use, but it worked perfectly for what they needed.
Okay, so once you figured out all the equipment, you run headfirst into an even bigger problem. How do you safely and legally mail a box that's full of chemicals? This wasn't just about packing things nicely. It was a massive health and safety challenge. And this quote right here just perfectly captures how wild the problem was. Shipping rules were written for huge industrial quantities. So you get this ludicrous situation where a courier might refuse to ship a kit that had less than a single gram of a substance just because it was technically classified as a dangerous good. The team had to fight through a mountain of red tape.
So to get around all this, they developed this incredibly thorough safety system. First, every single experiment was risk-assessed for a home setting. Any really toxic or flammable chemicals were swapped out for safer alternatives. Everything was packaged securely in sealed containers, inside absorbent bags, and on top of that, students got layers and layers of instruction, manuals, warning pages, videos, and that even had to complete their own safety audit before they could start an experiment.
So, after all that work, the clever design, the logistical nightmare, the intense safety protocols, we get to the most important question of all.
did it actually work? Were these students, working alone in their homes, able to keep up with the ones on campus?
Okay, let's just look at the data from a big study at Monash University. And the results, they're pretty staggering. Students using the home experiment kit didn't just keep up. Their average practical mark was 78.4%, which was actually higher than both the residential school students and the regular on-campus students. And then look at the final grades. Their average was nearly 73%, which was way higher than the other groups.
This chart makes that key finding impossible to ignore. When it comes to the core skill of practical lab work, the home kit students, again, working by themselves in their kitchens, actually did better than the students who had access to a full university lab at a professor standing right there. So, how is that even possible?
Well, the study offers a couple of really fascinating explanations. The first one is all about the students themselves. You see, distance education learners are often a bit older, they're generally more mature, and they are incredibly self-motivated. They've chosen this path, and they are deeply committed to making it work.
But here's the second reason, and this one is so counterintuitive. Remember how it took them a long time to set everything up? The researchers started to think that was actually a hidden advantage. It forced the students to become super familiar with the equipment and the whole procedure before they even started the experiment, which led to a much deeper level of understanding.
And what did the students themselves think of it? Well, a survey of that very first group found that a huge majority, 70% of them, said they actually enjoyed doing the experiments on their own. They really valued the independence and just being able to work at their own pace.
And this just leaves us with a really powerful final thought. Remember, all of this was achieved with technology from the 90s. We're talking DVDs and mail-order kits. But the core lesson here, that motivated learners, when given the right tools, can absolutely excel on their own, is more relevant today than ever before. It really makes you wonder, doesn't it? What's more important for real learning? A state-of-the-art classroom, or just a student's own drive and the freedom to figure things out for themselves?